Hello and welcome back to DoshTech. So today we're going to be using the Hyper TX3 EVO from Coolermaster. This is a tower heatsink, and we're going to use that to upgrade my 2013 PC build, which you would have seen back in 2013 when we actually built it. So you may be wondering why I'm upgrading the cooler. Well, that's because when I built it, I made one massive mistake. This noisy bit. This is the AMD stock cooler that they give out with their highest TDP CPUs. The Phenom 2 965, whatever you want to call it, has a TDP of 125 watts, so that's pretty high, and this is the stock cooler they give you with it. In terms of cooling, I did actually say in that build video that it has good enough cooling. Yes, it does actually cool it. Obviously they give it to you with the processor, and that's what they expect you to use, and therefore it is actually capable of meeting the requirements of actually cooling it. But unfortunately it's just so incredibly loud that it's just not really become acceptable. And obviously that was several years ago now, whereas games and that have got more advanced, and I'm having to push my ancient CPU harder and harder all the time, and obviously this little thing can't keep up anymore. So that's the reason I'm upgrading, because this thing will get up to 7,000 RPM sometimes when I'm in a heavy gaming or editing a video. And the problem with that, of course, is the fan is not going to last that long if I'm constantly doing that with it. But most importantly, it's got to the point it can't actually keep the temperature stable anymore. Whilst it used to be fine, it can no longer actually keep it at a stable temperature during modern games, like the new games that are coming out. It constantly goes up to 60 degrees, it's even been up to 62, which AMD do state is the maximum for that CPU, and preferably not take it any higher. So, slightly being cautious, but also I just want to get the thing a lot quieter, because this is definitely the main restricting factor for noise. So we're going to be fitting this, and we're going to see how much of a difference it makes. It should make it a lot quieter, and possibly give us a slight increase in cooling performance. It does actually say that it only has a max TDP of 130 watts that the TX3 supports. However, it therefore should be in requirements, and I'm still expecting it to give a slight, maybe 5 or 10 degree decrease, but obviously I'm not going to be doing anything like a scientific test, and obviously ambient temperatures will be something to factor in, because I was using this to a point where obviously you might not know, the room I use it in is quite a small one, and by that time a few hours of doing something and the room gets pretty hot, at which point it just cannot keep a sustained temperature. Once the room has got up to a higher temperature, it just cannot stay below 62 when the air it has to cool it down is just too hot. Anyway, enough rambling. This should solve my problems, hopefully, and we'll have an evaluation at the end and see if we've actually managed to do what I wanted. So let's get on and fit the Hyper TX3 EVO. Okay, so first things first, I'm going to remove the graphics card, because obviously I want as much access to this as possible, because it's not going to be an easy job, because heatsinks are notoriously painful. I'm not sure how difficult this one is. It seems like one of the most simple ones you can get, but that's what I thought about one of my friend's Freezer 13s. It did not turn out to be the easiest thing I've ever done. It was in fact quite the trial. A bit of a lesson for you next time, Gigabyte. Preferably don't put the 6-pin power somewhere it's actually blocked by the heatsink. Anyway, I don't know how this retention mechanism works on this motherboard. Push down. Apparently so. Could you come out? Oh, there we go. That was the problem. What are you stuck to? There we go. And here we have the GTX 650 Ti Boost. It's quite a good card and I've been enjoying it, but I need to do a bit of dust clearance before I put that back in, definitely. Okay, we're going to unplug the fan. And we're going to twist just the tensioner on the heatsink. Now I'll be honest, I've seen a lot of horror stories where people's processors get pulled out of the socket, because the AMD one of course doesn't have a mechanical retention on the top of the CPU. It's just sort of pulled into the socket. So I'm going to try and pull it directly upwards to avoid bending the pins if it does decide to come with it. Probably see the amount of force I'm putting through my hands. I don't really want to be putting so much on my processor, but I'm going to have to pull it up. Really does not want to come out. Okay, so some slight bodging later. It came off and it stayed in place. I'd like to thank Colin for that, because obviously I was far too terrified to break my own computer, but obviously he doesn't care because it's not his. There is the old heatsink. Apparently this turned into concrete and was impossible to remove. And it's also very hot due to the hand drive. I did try heating this up by going around a taxi in GTA 5, but obviously that was nowhere near enough heat. We obviously have to get the RAM out as well, if you haven't already noticed. Next step is to clean the top of the CPU. I'm going to try it with a towel first, but I highly doubt that's going to work. If so, I might have to get some white spirit or something. But next step will hopefully be setting up the heatsink, and then once that's done we'll put the thermal paste on, and then we'll get it all in place and put it back together and see if we've broken it. It's all dry. It is coming off. Oh, it's coming off the side and going onto the motherboard. Hopefully it's not conductive. So yeah, basically we just want to polish the surface so that it's in good enough condition to accept the new thermal compound, because obviously we want it to make a good contact. It's pretty clean. Yes, you just want to make sure that you've got all the thermal paste that was on it off. Firstly, so you've got a good thermal contact when you put the new stuff on. Secondly, you don't want it to get stuck on there again because of the old stuff still being in place. And thirdly, you don't necessarily want any of the old thermal paste getting onto the motherboard, because sometimes, especially the cheap stuff, is actually conductive. And obviously, conductive shorting across motherboard joints is a bad thing. Anyway, here is our Phenom 2 965 Black Edition. Apologies for the noise. Fan is on, it's too hot in here. Next step is we're going to get the heatsink out of its beautiful packaging, as we can see here. Might even switch to Colin's footage for this. As you can see, it's well packaged. Obviously I've already unboxed this though, so you would have seen it by now. Yeah, so basically 3 direct contact pipes. In other words, they're not in the block, they're actually directly touching the top of the CPU, so that should aid in the thermal, what do you call it, conductivity. 92mm fan on here. This is a much better fan than the one that was on it. Obviously it's bigger, which means it can go slower and provide more airflow. So, you know, win-win. And it's also PWM and shouldn't be the loudest thing on earth. So yeah, there's also the provision to fit a fan to the back, which I might do, providing there's enough clearance between the CPU and the RAM. Anyway, yeah, we'll get on with fitting this, and basically all the stuff we need is in this little box. So those are the brackets. We just need the AMD bits. So these are these bits. Strangely, this is actually this is sort of designed for AMD out of the box. You don't really have to change it. You can either have this bracket, this is the tension bracket as you've seen before, where it has the tensioner, it has a clip on that side, the tensioner on that side, and basically you tension it and that pushes this, there's a slight point in the middle and that pushes down on the middle of it. So you can either have it across like that in the slot, which you, obviously the slot is this way up, as you can see here. So you can either have it that way, pointing up to the top of the case if you have ventilation in the top, but obviously, as you can see there, we don't. So what we can do in this situation is take this and slide it through the back, and then that fits into some grooves that way, which means we can have it pointing out the back. And not a lot of heat sinks have that option, although it seems like a basic thing. It's actually quite a useful feature to have. So yeah, that's what we're going to do. We're going to mount it like that, and that will allow us to have it point straight out the back into my exhaust fan. So yeah, enough rambling, we'll get on and do this. That's upside down, that's not a good thing. Okay, you've got to hold it together, otherwise it doesn't work. Which is awkward because gravity. Anyway, so you're trying to peel that off. The reasoning for that is that that's now clean from the factory. You're not meant to touch this, so don't. Okay, here we have the world's smallest tube of thermal paste. And it doesn't matter how I do this, someone is going to be angry with it. So because it's an AMD CPU, it is slightly larger. I think it's slightly larger dies than an Intel one. I'm going to make sure I do the line method, which basically means I'm going to apply a small line down the middle. This means I get the most thermal conductivity as I could possibly get on there. Or I could just do the dot. No, I'm going to do the dot, I think. It doesn't matter, someone's going to be angry anyway. So I'm just going to unscrew the lid of this. I'll do it over the table in case it spills everywhere. Oh my god, that's tight. It didn't spill everywhere. Okay, let's just do a dot AP.
Hang on, wait.
Filming it.
My phone's getting very hot. It does that sometimes.
Okay, here we go. This is difficult in this position, I'll tell you that. That'll do. Wow, that's pretty crap. That'll do. I'll just drop the lid. Okay, so there's a little bit of a problematic mounting this heatsink. The bracket does want to fall off, which is annoying because I'm wanting to put it on all the time. Anyway, so yeah, the Intel one, you just need to screw the push pin brackets into the 8 holes around the outside. We don't need to do that though. Okay, basically we're just going to want to hook that on there, drop it into place. Well, that's a funny feeling, but that's... Smush it down a little bit so that we've got enough... There we go, right. It's under there. Now this is this important, as you can see, tensioning that. That's really tight, but it's meant to be. As you can see, that is now solidly on there. It's not going anywhere. My RAM is not going to fit. I might have to swap the fan to the other side, which is not necessarily a good thing, but okay. Or I could get less RAM, but I'm not going to do that. Nope, that's way too tall. Which is a shame, because that means I can only have one fan on this, but not the end of the world, I suppose. Basically, you just pull these clips back, and it will all just fall apart, basically, but it's meant to, so... There we go. There's the fan. It's quite a nice fan, actually. So I'm now going to be sucking through the heatsink, which is... It's okay, I suppose, it just doesn't look as pretty. What? Oh look, what they've done to be awkward is put rubber over the screws, which I suppose is a good thing for noise dampening, but it's not a good thing for swapping the sides around, so we'll just do that quickly. The reason I bought this heatsink and not the Hyper 212 Plus, which lots of people get, is that, wow really, is although my case supports the Hyper 212, my hope of using this one is that not only is it slightly cheaper, but I can use, I can hopefully keep my side fans in place, as I believe this should allow enough clearance for them to fit. make sure you don't put it the wrong way round, so it needs to stay in the same orientation that you took it off in. It was originally pushing through. If we keep it pointing this way, on that side it will keep pulling it through. So if we have it going that way, it'll be pulling away from my exhaust, and that obviously doesn't work. So we need to basically fit that bracket exactly the same as we just did, but it needs to be on the other side. So it does mean that these screws are going to re-tap themselves, which means they're going to be really difficult, but it's okay. I have an annoying amount of excess cabling, but it's okay. That horrible noise is normal. Click. Well, there's no click, but you can see it going on. It's quite tight, but you know, that's good. There we go. There we have the fan in place on the motherboard, attached to the heatsink. All we've got to do now is make sure we plug the cable in to the right place. That's plugged in, and it seems to have put itself out the way pretty well, actually. So we're now in place. It should now be pulling air through and pushing it straight out the exhaust. So it's also much more well lined up than it was before, as obviously it was pointing down. Now it's going straight through and out. So it's just a better design all round. What we're going to do now is refit the RAM, because obviously I need 16 gigs of RAM. Yeah. Also, another thing that's changed since the original build video of this computer, other than the side panel fans, is the 24-pin motherboard connector has actually been properly seated, whereas before, when we originally built this wasn't actually clicked in all the way, but as you can see now, the clip is flat down, so I did actually manage to get that fitted properly at a later date. Otherwise, the main attraction we're here, the TX3 EVO, is now fitted, and hopefully I don't have to take my side panel fans off. If it does, I'm not going to be that happy really, but okay, so now I'm going to refit the graphics card. Take it to the top slot here. Bit of a tricky thing with a card that's a few inches long. I'm not quite sure the length of this. Not exactly sure on the length of this, but it's quite long. Click, please. There we go. Right. He's in. Let's just get the 3 screws for the PCI brackets. The reason I have to take out 3 is because the one for the Wi-Fi card, yes, I use Wi-Fi, don't judge me, actually sort of blocks that one from being removed. We'll put those back in now. And I'll try not to drop it like I did in the last build. There we go. Wi-Fi card. In we go, there we go. Don't want to go mad tight with them, you just want to hold the card in place really. So yeah, as you can see it's now a lot cleaner than it was. Yeah, that's it. That's all barked together, but obviously we don't forget. We will need PCI power, otherwise the graphics card will do nothing. Click. In place. Wonderful. I think that's the computer back together now, unless there's anything forgotten. We did test this earlier. This does actually fit, so I can actually keep my side fans in place. I'm going to go into the BIOS to check the temperatures. Yep.
Oh.
Okay, that's a good thing. Not going to cheer erratically like we did the first time. I think that went to the BIOS. Yeah. Temperature 31. That's the coolest I've ever seen it. 32. We'll just leave it here for a moment. I'll just sort of browse. That is really sensitive, Christ. What is it? It's a monitor. 33. I think usually it was like 40, wasn't it? The BIOS. When we first did this with the stock cooler. going up slowly, but that's to be expected. We'll boot into Windows and we'll, I've got Core Temp open. I've always had that open, especially with stock cooler. I recommend having that open in the toolbar all the time. Yeah, we'll go into Windows. You don't need to launch start it, don't worry about that. Already this is a lot quieter. It used to sound like a jet engine before it even got to the OS. But now it's mostly hard drive noise, which is, oh yes, my background. We'll ignore that.
Say nothing about that in the video, that'd be hilarious.
Yes, hopefully it's not in a good enough focus to see some of the file name. Stop zooming in.
That's good, so we did something that actually worked for once. That's quite impressive, that. Let's see what sort of temperatures we're getting there.
Okay, so the temperatures are... I've tried to go to a busy part of the city here. This is GTA 5 if you don't know. Temperatures are about 52, which is at worst times about 10 degrees cooler than it was. But it's gone up to 53 once or twice. But the temperatures are better than they were, and I'm perfectly happy playing a game at 53 degrees for a while, for quite a long time. And most importantly, it's a lot quieter than it was before. So that's GTA 5. I'm now going to try another game, Euro Truck Simulator, because that's a game, it doesn't get quite as hot, but it does get quite hot, and it's a long, sustained thing, because obviously some of the journeys I do in that are a long time. So we'll jump into Euro Truck and see what sort of temperatures and noise we get. Okay, so this is Euro Truck Simulator 2, a game I used to play a lot until I started having heat issues. It used to run at about 56 degrees constantly, but that's sort of changed now, as you can see on the screen here. That's the GPU temperature. It says here 45, so that's quite a dramatic improvement. So all in all, I think this has been a great success, and yeah, so that's the heatsink upgraded. Ignore the wind. That's the heatsink upgraded. It's made it quieter, and it's cooled it down somewhat in some games. So, well, it just cooled it down a little bit in general. As I said, it's not really a cooling upgrade, it's more a noise upgrade. It's a lot quieter than it was, and that's the reason I did it. So technically, we've managed to do what we set out to do, so that's a good thing. Anyway, thanks for watching, and I hope to see you again next time on DoshTech.